So we're going to move the trig that you are doing, SOHCAHTOA, onto a coordinate plane with an origin 0, 0. Okay? Yes, there is graphing this semester. All right, so you have your coordinate plane, right? And so with the origin at the center, and just so everybody remembers the direction that it goes, we call this one quadrant 1. Okay, we know that quadrant 3 is across from that, but where does it go in the direction of like which one's 2 and which one's 4? You know how that goes? Okay, it goes counterclockwise. So it goes from 1 here to 2 up in the upper corner. This is 2 and this is 4. So I do need to make sure that we all are on the same page for that. When you draw a right triangle on an axis like this, let me show you how you're never going to do it. You will never draw a right triangle like that. Okay? The reason is that the B side, the side that we call B, always has to be on the x-axis. Okay, B is the bottom, so it always has to be on the x-axis. So we're never going to draw it like that. So when you draw a right triangle, you're going to draw it like this. That's in quadrant 1. If you draw it in quadrant 2, it's going to look like this. If you draw it in quadrant 3, it'll look like that. And if you draw it in quadrant 4, it'll look like this. I like to say that they make like a bow tie. Okay, it looks like a bow tie shape to me. If you get your triangle flipped a different direction than one of these in the quadrant, if you flip it backwards or upside down or something, all your numbers are going to be backwards from what they should be. So this is the direction. Okay, so there are a couple rules of thumb that we have. Some, if you want to write, if you have room on your notes to write it next to, or you can write it underneath. But here are the rules. Number 1. The hypotenuse must start at the origin. Okay, the hypotenuse must start at 0, 0. So a couple ways people might do it incorrectly. They might try and draw a right triangle like this. Okay, yeah, and immediately I could tell that that's not right because the hypotenuse doesn't connect the origin at all. And so that would be the wrong way to do that. And so we'd have to say, no, that's not right. Okay, number 2. Side B must always be on the x-axis. So again, I can tell if I'm looking at a triangle and I don't see side B on the x-axis, then I know that you've got it rotated the wrong way, and all your answers are going to be backwards. And then number 3. Angle theta. Okay, now that we are on a coordinate plane, you use theta instead of alpha and beta. Angle theta is always by the origin also. So what we're going to do is we're going to go back to our 4 triangles that you just drew. Hopefully you made them big enough that you can label the different sides. So I'm going to go back here. And let's look at quadrant 1. All right, we know that this is C, that's the hypotenuse. The hypotenuse always has to touch the 0, 0. Here's B. B is always on the x-axis, and it is. So that means A is this one. So we've got our A, B, C. And then theta is always by the origin. So theta is going to be the angle right down there. So that's how it's going to be labeled in quadrant 1. Next to it, in quadrant 2, we also have C as the hypotenuse, and we have A as the vertical leg, but our bottom is negative B. So why is that negative B? Yeah, because we're on the negative side of the origin, and so we're on the negative side of the x-axis, and so that's going to be that, Daniel. And then we've got theta as the angle right in there. So then we move to quadrant 3. It also still has negative B, and its A side is also negative, because when you're in quadrant 3, those sides are all negative. Remember how we were doing Pythagorean theorem yesterday? We had plus or minus. Here's where some of the minus sides will end up in quadrant, depending on if it's B that's minus or both of them that are minus. But C is always positive. The hypotenuse will never be a negative number. The hypotenuse will always be positive. Just 2 squares always make a positive thing. And theta is the angle up by the origin again. And then so the final one has a positive B because it's on the right side of the x-axis, but it has a negative A and it has a positive hypotenuse with theta in the origin. So those are the 4 ways to draw a right triangle in the coordinate axis. Okay, any questions about that? All right, so here's how it's going to go. Oops. Our first example. All right, draw a right triangle through point P, and the position of point P is going to be 12, comma, negative 5. And then find the 6 trig values for theta. So what we got to do first is figure out where point P is, what quadrant it's in. Once we know the quadrant, then we know the shape of the triangle we have to draw. And we have to know where to label all the sides. And then we'll find the 6 trig values. So it's not too bad if you can visualize it. So we're going to draw our picture first and get the triangle all in the right spot. So here's our coordinate. We want 12, negative 5. So what quadrant will 12, negative 5 be in? Positive 12, then negative 5. Where's that going to put me? Quadrant 4. Okay, it's going to be about, we'll say over here. Okay, it was 12 and negative 5. So that's P. The right triangle has to go through there. So the hypotenuse has to start at the origin and then connect to point P. So my origin is here. So my hypotenuse will start at the origin and connect to point P. Then I know the shape of this has to be part of that bow tie shape, and so I gotta go up to here and across the x-axis. So every once in a while, someone will make their triangle incorrect, and they'll go from P over to the y-axis and try and make their right triangle that way, and then they end up with all backwards numbers, and everything ends up opposite of what it should be. So that's how the triangle should be drawn. So now we're going to label, and we know that this is 12, and it's positive, so it's on the right side. We know that the A value is negative 5 because it dropped down 5 units. And then I'm going to need Pythagorean theorem to help me figure out how long the C value is for the hypotenuse. So I'll do a little quick scratch work and figure out what A squared plus B squared equals C squared works out to be. So that's 12 squared plus negative 5, comma, or parentheses squared equals C squared. So I'll do a little quick work on that. That's 144 plus a positive 25 equals C squared. That gives me 169. equals c squared. So c is the plus or minus square root of that, which is perfectly plus or minus 13. But the hypotenuse is always positive. So you don't ever have to worry about the hypotenuse being negative. So we know that our c value right now is confirmed to be the number 13. And then theta is put in the corner by the origin. So theta will be right there. As long as you get everything labeled right and not backwards, then your 6 trig values should come pretty quickly. So then you're going to do those 6 trig values. So I've got that drawn, and so I'll do sine theta followed by cosecant theta. So I'll do those two first. Sine of theta is opposite over hypotenuse. The opposite from theta is what number right now? Say it again. -5. Yeah, the opposite is -5 over the hypotenuse, which is 13. What we'll traditionally do for that is, instead of writing the negative necessarily by the 5, is typically you'll see it written with the negative just kind of in front of the whole problem like that, instead of just with the 5. I'm not going to mark you right or wrong either way. Okay, so the negative can be, either way is fine. But when you flip it, then you're going to have 13 on the top and 5 on the bottom with the negative still out front. So that's how you do sine. Then you'll do cosine. Cosine would be adjacent, which is 12 over 13, which is the hypotenuse, and then secant. So those two are a pair, and they go together. COS and SEC go together. And then tangent, cotangent go together as well. So we'll do the tangent would be TOA. So opposite over adjacent. That's -5 over 12. And again, I'm going to write the negative just sort of in front as opposed to next to the -5 or the 5. But I'm not going to mark you wrong either way. And then tangent, cotangent, excuse me, of theta will be the reciprocal of that, which is negative in front of 12 over 5. I would mark you probably wrong if you wrote the negative in the denominator. Like if you moved this negative right here down to by the -5, we never put negatives in the denominator, so that's why I usually just put my negative out front. So as long as you get your triangle right, then the 6 trig values just sort of come, kind of perfectly right in there. Okay, any questions on that one so far? Okay, let's keep going. I have a couple more, maybe 2. Okay. Construct a triangle where the sine of theta would be equal to 3 over 7, but the tangent of theta is negative. In other words, tangent is theta less than 0. And then find the remaining trig values. So first we've got to draw this triangle and make sure it's in the right position. So we know that sine is 3 over 7 and tangent is supposed to be negative. So this is what I would recommend that you do. Okay, draw your coordinate axis and then get ready with your 6 trig things. And just kind of make yourself a template every time, and it sort of becomes fill in the blank. And I would just then kind of do, sort of fill in the blank thing. We know that sine is 3 over 7, which means automatically we know which of the other trig values. Cosecant comes right with it, right? So 7 over 3. We also know that tangent has to be negative. So I'm going to put a negative in my tangent. And if tangent is negative, what else do we know? What else has to be negative? Cotangent has to be negative. And if those two are negative, that means that actually something else has to be negative as well, which is cosine. Because you can't have a negative tangent unless either sine or cosine is negative. One of them has to be negative. And so cosine is negative, which means secant is negative. So I can tell all of that by sort of doing a fill-in-the-blank thing. Then I'm ready to draw my picture. Since I know that sine is 3 over 7, I know that has to be the opposite side, and that has to be the hypotenuse side. Okay, so I have to have 3 over 7, which means my triangle is either going this way or it's going this way, because it's 3 as the opposite and 7 as the hypotenuse, or 3 as the opposite and 7 as the hypotenuse. It's one of those two things. I have to eliminate quadrant 1 because I know that parts of this, something has to be negative here. And in quadrant 1, nothing's negative. Everything's positive in quadrant 1. So that's going to help me eliminate quadrant 1 as an option. So I'm going to get rid of that. And I'm not even going to have it as a choice. Which tells me that my b down here has to be a negative number. So then I can do Pythagorean theorem again to help me figure out what that b needs to be. So I can have 3 squared plus negative b squared equals 7 squared. So that's 9 plus b squared equals 49. So b squared is 49 minus 9, which is 40. So b is, I know it has to be negative, so it's the negative square root of 40, which Daniel was asking about simplifying, and that can be simplified to the negative 2 of the square root of 10. So now I know what my b value is. It's negative 2 rad 10, which then allows me to complete the other trig values. So negative 2 rad 10 is now the value of the base. So now my cosine value will be adjacent over hypotenuse. So it'll be negative 2 rad 10 over the number 7. So the secant is the flip of that, which will be negative 7 over 2 rad 10. And then tangent is TOA. So it will be negative 3 over 2 rad 10 and negative 2 rad 10 over 3. And again, the negative just hovers out in front of the fraction rather than being associated with necessarily numerator or denominator. Okay, how are you doing on that? That'll sort of make sense? I'm going to do another one like that because it's a little bit of more thinking, and then we'll be done. And you'll have a little bit of time at the end. All right, so here's our last one for today. So it's going to be similar. Construct a triangle. They might call it in the book a reference triangle. The word reference triangle just means that they want you to put it on a axis, okay, on a coordinate grid. So construct a reference triangle with secant theta being equal to 3 and sine of theta being positive, greater than 0. Okay, secant of theta is equal to 3, and sine of theta is a positive number, greater than 0. So my best advice again is to construct yourself a blank grid and have your 6 blank excuse me, trig things, and then just sort of work on filling in the blanks and see how far you can go before you get stuck. So start with sine and cosecant. Those two go together. Cosine and secant, those two go together. and tangent and cotangent. So I usually just sort of make that template, 6 trig values, and then see what I can go. All right, I know that secant theta is 3. What does that tell me about cosine? What does cosine have to be in order for secant to turn out to be 3? It had to have been 1 over 3, because they are reciprocals of each other. I also know that sine is positive, so sine's going to be a positive number, which means cosecant will be a positive number. I already know that cosine and secant are positive as well, so I have 4 positive things, which means all of them are positive. If the first 4 are positive, everything's positive, because that's going to put me in quadrant 1. If everything is positive, I'm in quadrant 1. So now I can draw a triangle in quadrant 1. So I'll go ahead and do that. And I want to label. Since cosine was 1/3, I know that adjacent is 1 and hypotenuse is 3. And so if adjacent is 1, adjacent is always that b value. Hypotenuse is 3, and theta goes in the corner by the origin. So then again, I'll do a little Pythagorean theorem work to help me figure out what the missing a value is. So it'll be a squared plus 1 squared equals 3 squared. That's a squared plus 1 equals 9. So a squared is 8. So a is the plus or minus square root of 8, which simplifies to be the plus or minus 2 rad 2. But I know it's not going to be negative 2 rad 2 because I'm not using any negative numbers in this question. It's going to be positive 2 rad 2. So now that I have positive 2 rad 2 as my final side, I can go back to my blanks and fill in the remaining values. So now I know that sine is going to be opposite, which turned out to be 2 rad 2 over hypotenuse, which is 3. And then cosecant is the reciprocal. And then tangent would be TOA, so the opposite, 2 rad 2 over the adjacent, which is 1. And so cotangent would be 1 over 2 rad 2.